How about now? There we go. I think we're back. Well, none of y'all could hear me. So what I was saying was that this is our first time doing a virtual meetup for Orlando IoT, and so we're still kind of working through our tech stack. So bear with me if you guys have any major issues with sound and video. Please let us know in the live chat. We've got Al monitoring the chat, and we'll pipe in with any sort of comments you guys have. So let's get started here. If I can get us moving here. All right, our agenda for tonight. Right now we're in our intro. Next up, Siva is going to give us a really cool talk on adding intelligence to the edge. If you're in our Orlando IoT meetup group, you may have seen a really neat GIF that Siva put together. I can't wait to see how he did that. After that, we'll probably break for a couple minutes, and then we'll come back with Javier, who is going to talk about how to get a job in the IoT space. Excited to hear what he has to say. This is a combined meetup, so I wanted to give you a little picture here of all of our organizers. We've got from the Google Developers Group, Hendrix and Javi, Hendrix will give us some words here in a minute or two. And then from the Orlando IoT side, we've got Al, myself, and Jared, who are your hosts. Okay, so I do want to give a shout out to our Orlando IoT Slack. If you guys would like to join us, we talk about IoT related things, answer questions. If anybody's stuck, we got a pretty good community here. I'd like to hop in and help you out with your IoT projects. To join, you can find us at our IoT website, which is orlandoiot.com, or you can email Jared. You can see the email there. I think it's Porcenalic, jporcenalic@gmail.com if you want to join. Or, of course, you could message us at meetup.com for the Orlando IoT meetup. Today, if you are live streaming the live stream, you are welcome to tweet us at hashtag Orlando IoT Meetup, and can't wait to see what you guys can come up with. All right, I'm going to hop it over to Hendrix here. Let's see if he's still, yeah, looks good. Hendrix, you want to give us some information about your upcoming meetup?
Yes. First of all, I want to welcome everyone to our first of its kind meetup in terms of being online, given the time. But we are doing it enthusiastically as always. We're missing the pizza and the beer and all the other stuff that comes with a live, with the kind of in-person event, but we're still great. We're happy to see a lot of people on the streaming channel. I want to take the opportunity to invite everyone to our next meetup. It's coming up April 23rd. We partnered with the Google Firebase team. They will be doing some kind of Firebase introduction, as well as they're going to make themselves available to answer any type of question you might have would relate to Firebase. It's going to be our first of its kind of thing. They are limiting the event to 25 seats. The reason for that is because they want to make themselves available to kind of go over any questions people might have. We might do it again, depending on the demand. So please join us. The link is in our meetup, which is GDG Central Florida. So please check us out. Thank you.
Great, thanks, Javier. Cool. All right, and I guess I'll pitch our next Orlando IoT meetup. We have a meetup on Wednesday. Pretty sure that's May 6th, not March 6th. Let me double check that that is in fact a Wednesday. It is Wednesday, May 6th. We're not sure who's going to be talking yet, but we've got a couple cool speakers lined up. So watch our meetup page and our website if you would like to hear more about that. All right, well, with that in mind, I think I'm going to hand it over to Siva here for the presentation. Siva, can I get you to share your screen and then I'll drop you in? Okay, here we go. I'm gonna hand it off. Make sure I get the audio working.
Is it working? Can you hear me? Okay, good. Um, so today we are going to talk about adding intelligence to the edge devices with Cloud IoT. Uh, I'm like close to the both of the meetups, Orlando IoT and as well as Google Developer Group Center Florida. Some of you already hear this demo from me. One demo is like about the IoT, and the other demo is about like the cloud AutoML. So this time I'm going to combine together and present like how AutoML can be used in the IoT devices. So that's our today's topic, like how to add intelligence to your edge IoT devices with the Google Cloud IoT. So the agenda of today's session is going to be like, I'm going to give a brief introduction about what is IoT and what does that mean is like adding intelligence to the IoT edge devices. And then if you want to add intelligence, you need a machine learning model. So we are going to walk through that like a different approaches, how we can train our model, how we can train our machine learning model to run it in your IoT devices. And the third step is like what are the devices we can run and what are the special use cases we can use this edge devices approach, and also look how we can run this on IoT devices. Can we do the fast inferences in the devices? So those are the questions we are going to answer. And finally, a short demo. I have already shared this demo in our Orlando IoT Slack. This demo is about like we are going to train a model, and that model is going to detect whether I am touching my face or not. So this is kind of like a awareness to this COVID-19 situation. Can we train a machine learning model to detect these kind of use cases, and how fast we can infer that using the IoT devices? So that's what we are going to show today, and that's our agenda of this session. And a brief introduction about me. I'm Shiva, working as architect in CEI, Computer Enterprises Inc. And I'm focusing on cloud, mobile, and IoT solutions. And I'm based on Orlando, Florida here. You can follow me at my Twitter handle at ksivamuthu. So let's start with IoT. Everyone know like what is IoT, Internet of Things. So IoT is the concept of connecting like any devices to the internet and to other connected devices as well. So not only like connecting your device to the internet, we can like imagine the use case where devices can talk with each other and form a mesh network kind of stuff, so that all the data can be integrated together and sent that to the internet through the gateway. So that's how like the IoT work, and that's the IoT concept. I will try to explain that in the simple terms. The IoT has like three major components. One is sensor, where it's converting your electrical energy into that physical energy into that electrical energy. And there is a control center. So this is where like your decision power, everything is going to be in the cloud or in your gateway. So the control center makes the decision based on the data that's coming from the device. And there is another component called actuator. Actuator, nothing but like it converts your electrical data, or like electronic data, into the physical energy, right? So here we are taking like the plant watering system. So in the plant watering system, we have this soil moisture sensor. The soil moisture sensor is continuously detecting like what is the water level that's going on in the soil, right? And it's sending that data into that control center. And the control center decides like, okay, this soil water level is like going above or below the threshold. Now we need to take some action. And that action also is sent by the control center to the device. And device is like getting that action. Okay, the soil moisture level is low. Now I need to switch on the water pump. Or if the soil moisture level is high, now I need to stop the water pump to make sure it's not overflowing, right? So these are the decisions we can take in IoT device. So I'm just explaining like one of the workflow where IoT comes into the picture. like the sensor sending the data to the cloud, and the cloud is making the decision. And based on the decision, we are sending back like control to device again, and device is making some action based on that. So this is pretty much every IoT device work, at least like it follows the similar pattern. And now Internet of Things is like we cannot imagine without any IoT devices, because we need like more and more data to analyze like what's the behavior, and we are making sure this data is very useful for us to make like future prediction or like future better output. And also we need like more data to analyze, and that data is coming from all these devices. Example like the agriculture automation, and also like the daily wearables like your Fitbit or any other devices you are wearing. And also now in the case like the telemedicine, healthcare. So in these things also like we are using a lot of IoT devices. So wherever we are possible to get the data, we are getting the data, not only like keeping it in the device, we are sending that to the cloud, right? And from the cloud, we are making like a lot of analysis and the decision making based on the data. So the data and the IoT devices, and where you are doing like analysis and everything in the cloud. So all these three together, that makes like and it's giving like bringing a technology into like new level of that consumption, right? And it is predicted that like there will be 41.6 around like 50 billion connected IoT devices, and also it's generating like 80 zettabytes of data in like in 2025. It may be like increasing more based on like how it's evolving right now. But think about like how much data every device is sending to the cloud, and also like how much devices is connecting to the cloud. Right? So to manage this kind of like a massive amount of data and massive amount of devices, we need a managed cloud IoT services. So the Google Cloud is providing one of those managed IoT services that is called Cloud IoT Core. So the Cloud IoT Core, the main purpose of the Cloud IoT Core is two things. One is it's managing the device. It's making sure your device is provisioned. Your device is like able to update the firmware, and you are able to configure or modify the settings in the device. And the second thing is we need a solid framework where you can ingest a lot of data from the devices, right? And also you need like the components behind that where you can analyze that their data in the cloud. So this is the overall architecture, like how cloud IoT works. So you have like a lot of devices here, and the data is sending to the cloud IoT core. So this is where the managed IoT services come in. All the data that's published using like the PubSub model, this is kind of like an event hub model where it's like continuously ingesting the data into the platform, right? And using the PubSub, we are using data flow. This is the orchestrate tool for your data. So this data flow, making sure your data is sending to the big table for storage and also BigQuery for analysis. So once you get the data, then at the time only the Cloud ML coming into the picture, where the Cloud ML is taking care of analyzing the data from the BigQuery and sending the trained model back to the data flow for sending that into the devices. So this how like overall it works, making sure all the data is like ingested to the storage, and also like all the devices that can be managed through the device management API from Cloud IoT Core. So as I have explained before, like there are a couple of functionalities in the IoT Core that is like bidirectional communication. So this is where like you are having this sensor and actuator logic is coming in. So we are able to get the data from device, and also we are able to send the data to the device. And also it's working with the familiar platform and protocols like HTTP or MQTT protocols specifically designed for IoT devices. And it has like inbuilt security enhanced solutions like the certificate and also who is going to provision and who is going to get the data. So those are the security mechanisms that's inbuilt with the Cloud IoT core. And also it's taking care of like logging and monitoring and making sure the automatic device provisioning happen, and also you can push the firmware update to the device. So all this functionality that's inbuilt with the Cloud IoT core, the only thing is you need to connect with the appropriate SDKs and making sure you are able to push all these things from the Cloud IoT code to the device, and as well as you are able to get the device telemetry or metrics from device to the cloud. Okay, so that's the overall introduction about like what is IoT and how Google Cloud is like managing these IoT services, right? So that will give you like the overall picture how you are going to scale up the IoT devices in your real business case. Now we are coming to the next set of things. How we are going to add the machine learning or artificial intelligence to the device, right? Because the devices are in the field. Think about like this: the devices are in the field, and we don't have like control to the device always. Especially like these kind of IoT devices, that would be more helpful where people cannot reach, right? For example, I have worked on one of the mining industry. So they have developed a gas sensor, and that sensor is detecting like whether there are poison gas in that mine or not, right? So the worker will wear that the gas sensor, and the gas sensor continuously monitor that the poisonous gas levels. And if it is above the threshold, it would immediately alert the supervisor, right? So think about those kind of scenarios. We cannot update the device often, but that device is going to take some life-saving decision based on some intelligence, and that intelligence we are going to build using the machine learning and deploy that in the device. Right? So for that purpose, Google Cloud is providing some of the artificial intelligence building blocks. It has like, in fact, like it has a spectrum of building blocks. One is the left-hand side, it has the machine learning APIs, which is built using pre-trained models. What is pre-trained model is they already have the data, for example, detecting the face or what color that object is, or like you can detect whether it's a celebrity or the landmarks. So we have like already established data, and Google built the pre-trained model APIs so that you can query that API and detect like what that object is or what are the features in that image, right? And in the same time, in the right-hand side, they have like the custom machine learning images also. For example, if you need to create a deep core or deep learning VMs on by your own algorithm, or you want to tune based on your hyperparameter. So basically the data scientist and practitioner, they have like a deep learning VMs and engines algorithm. So they are going to deploy that on their own. So Google is providing the functionality to give this infrastructure and also to have these kind of powerful devices to make sure your training is running on that VMs, right? So it's giving that kind of spectrum also. But you have like a custom business case, but you want to like build with a less machine learning expertise, right? For that, they have brought a Cloud AutoML. So the Cloud AutoML that comes in like a right middle of this spectrum. It's based on your custom business cases. In the same time, you don't need a machine learning expertise like building your own deep learning algorithm or something. The Cloud AutoML, what does that do is it's taking your data and making sure it's building the high quality training model by itself, because it's continuously like improve by itself by doing multiple iterations. And finally, it will give you the best model to run your inference, right? So your inference. So that's how this Cloud AutoML works. The first thing we will see like what are the machine learning APIs, pre-trained models. So we have like the labels to detect the common entities, and also the face detection. The OCR is the famous one. You can like read the text from books or like images. and landmarks and the other services such as like searching, OCR, or even like the product search. So these are like machine learning APIs with the pre-trained models that is already available in the cloud. And from the right-hand side of the spectrum, the Cloud ML, as already discussed, like they are giving the infrastructure, not only the infrastructure, they are giving like the complete workflow pipeline as well. So you can pre-process your data and make sure you can orchestrate your machine learning workflow. It's like a data flow pipeline, and also a lot of analytics tool and the analysis tool in the data lab that's going to analyze your machine learning models. And finally, the output of that machine learning model is the TensorFlow. So you can just like either train and scale the TensorFlow at like the high level scaling, so that like it's providing as like infrastructure and also the machine to deploy your machine learning models. And these are the couple of TPU offerings, because for the machine learning, we can use like the flexible range of the machine learning operational models. One is like you can use CPU. The next stuff is like the GPU, and the FPGA is like the field gateways, and also they are giving like the ASICs. So these are the different computer models so that you can train your machine learning on this stuff. So they have this Cloud TPU offering, the Tensor Processing Unit. So here you can see like the Cloud TPU V3 pod. It's using like 100 plus petaflops. Petaflops means like they're doing operations per second. So 100 plus petaflops is giving that kind of support when you are training your machine learning in the cloud. So you can choose like what are the different cloud TPU based on your volume and also the scale of your machine learning training. Okay, now I'm going to show some of the demo in the Cloud AutoML. If you have any questions, let me know. Give me a second. Okay. So now we are going to talk about the mid of the spectrum, like the Cloud Auto.
Oh, hey, Siva, real quickly. We do have one question on the chat.
Yes.
And so the question is, what's an ASIC and how does it differ from an FPGA?
Okay, ASIC is like I'm going to cover some of those stuff in like a few slides. ASIC is like the Edge TPU kind of model. So it's like the system integration circuit. I'm not sure like what is the A. So it's like the system integration circuits that's making sure your TensorFlow like model is like making a high quality and also a high speed inference as well. I will show one of the demo. I will show like how it's going to differ from running in the CPU and also in the Edge TPU. That is like the ASIC model. Okay. Does that sound good? The next thing I'll go is the Cloud AutoML. So how AutoML works is you need to provide the data set. It may be image or text or any other data set. And that will submitted to the AutoML. So the AutoML is like inbuilt doing this training and making sure it's finding the best fit model on its machine learning algorithms. So it's going to continuously try like the different algorithms, and based on your data set, what it's going to be the best fit for that model. So it's going to take the best fit model, and once the training is completed, we can deploy that model into that cloud, and also we can deploy that into the edge devices. Like you can run it in the browser, or you can run it in the iOS or Android phones, or even you can run it in the Raspberry Pi. So there are like two different types of hosting available. One is do the prediction everything in like the REST service itself, and the second thing is you can do the prediction on like offline devices, right? So that's how the AutoML is working, and it has like a different products in the AutoML. One is the AutoML Vision, where it's doing the classification of image and also like detecting that object And also it has the natural language available where it can predict the text and the category of the text. So you can do those kind of text level prediction. And also it has the AutoML translation where it's doing like a translation based on the customer. So AutoML is AI to build AI. It's kind of like an artificial intelligence agent. It's building a high quality learning model with optimal architecture. Okay, now I'm going to show the demo of this one. This one I have already shared with you. So I have built a artificial the AutoML model. So this model is going to detect whether I am touching my face or not. As you know, like right now, the COVID situation, the one of the best advice we need to follow is like we don't need to touch the face because our hand may have germs and that is easy to get entered into your face, right? So that's one of the advice everyone is following. So I took that example and see like whether AutoML is able to detect whether I am touching my face or not, right? So for that one, I have built this AutoML vision set. I will show how that looks like. Give me a second. So this is a Google Cloud platform, and we have this AutoML vision API. And in this, I created a data set like a COVID AutoML. It says like cover AutoML because my Mac has a typo. So here I have uploaded the images. Here you can see like it's around like 295 images. So I have uploaded my images and also some of my colleagues' images. And also I have uploaded some of the face data sets that's available in the public, right? So what I did is I went through each and every image. So here I'm touching my face. So I labeled that as danger. And there are other images. For example, here in this image, he is not touching the face. So we label that as a safe. Similarly, we have uploaded like a lot of images. In fact, like this images I got from the colleagues and also like the public data set. I did it in like multiple trainings. The first training, I need to do like the label it every image manually, right? Because the system, the AutoML machine learning, it didn't know what I am going to train. But after that, I did like a, for example, I uploaded like some of the JSON and Richard images for the second training. At the time, it auto detects based on the previous training, and it started doing the new training. So what does that mean is, for every new image data sets you are adding, you are not doing like the training from initial stage. You are basically like you are transfer that learning. So whatever parameters it learned from previous training, that is transferred to the next set of training and making sure like your model is fine tuned based on the new set of data. So that's how the AutoML works in picking the scenes. But from user perspective, you are just like uploading the images and making sure you are labeling it in the correct category, like a danger or safe. And then once you have done with this labeling, you can go to the train tab. And in this train, you can train the new model. And it will ask a couple of parameters from you. One is how you are going to serve this model. Is it cloud hosted or edge? If it is cloud hosted, it's going to serve through the REST API. If it is edge, you can deploy that in the mobile, right? So here I have choose a edge, and then it will ask like what is your trade-off, right? Are you expecting like the higher accuracy, but it will infer slowly, right? Or if you want like the faster prediction, but the accuracy would be lower. And here I choose like the best trade-off, find the midway between like the higher accuracy and also like the fast inference, right? So you can choose this, and once that is done, you need to set the node hour budget. What does that mean is we are giving the instruction to the machine learning algorithm, like take maximum of 3 node hours. Right? Node hours in the sense like how much time the node is going to use. So you can set like a 3 or based on your image sizes. Here I have chosen 500 images, right? But if you want like more images, like 10,000 images or between 1,000 to 10,000, you can choose that node hours. And the node hours is like the maximum hours. For example, here I have choose like 3 hours, but my model, everything is like trained between and 1 hour. Yeah. Any questions?
No, I haven't seen any questions in the chat.
Okay. I thought like you were signaling.
Oh, sorry. No, I just keep touching my face and feeling weird because you're talking about not doing that.
Okay. Yeah, you can set your budget like 3 node hours, right? But in my case, it's trained in like within 20 minutes or something. So based on the data and how much category you are putting together, the budget will be increased, and it has like a yearly termination policy. So once your model or like once your best fit model is found, then it would be stopped. And once you start the training would be completed, and you can see like how your model is performing. Right? So here I'm seeing the full evaluation, and this is the confidence threshold. So you can increase the confidence threshold and see like how your model is performing here. And also it's giving like the precision and recall rate. So based on your confidence score, this would be changing. For example, if your confidence score is like a 0.5, the recall rate is like slowing down, right? So you need to adjust your data to make sure like you are getting your desired precision and recall rates. And also it's giving the confusion matrix. So this is where like the AutoML is suggesting you are having like a false positive or false negative between these categories. Here we have like the 14 images used for testing and 15 safe images used for testing. Both are like identified as the correct matrix. So this is like a kind of like a perfect thing. But if you go with the first model I have trained, sorry, the second model I have trained, the second version of training, you can see like it's confusing between the danger and safe label. So one of the images is like it couldn't predict whether it's safe or danger. Right? So those kind of analysis you can do before using this model. And once that is done, then you can use this model by exporting that. Right? Since I have trained using Edge model, I cannot do the online prediction, but you can use the model in like a TensorFlow-like TensorFlow.js, where we can run the machine learning in JavaScript, and Core ML for iOS and macOS devices, and also you can export that into the Docker container. And finally, the Coral devices. So this is where we are going to run it to make fast inference. Right? So with this one, first I have exported using TensorFlow.js. I will show that demo, how it works. So this is a plain React app where I have installed this TensorFlow.js, and I exported the model from the AutoML and making sure that is in this website. Right? Okay. Now I am allowing the camera and I'm start recording. This is like continuously iterating and making sure this is detecting whether safe or not. Right? It will take some time for the first training. Or maybe, I don't know what's going on here. Yeah. So now I'm like taking hand out of my face. It's detecting like safe. But if I'm having my hand on the face, it's starting detecting like danger, right? So I'm removing it again. Now it's like detecting as safe. So this is how it works. So basically, this is capturing that image from the webcam and continuously running this inference in the TensorFlow Lite.js in the browser itself. So from the browser, doing this one is like pretty fast here, right? So it's immediately detecting like at least danger, and if you're taking your hand, it's like safe here. Initially, I have uploaded only my images, so it's kind of like a more biased to the data. It couldn't detect like my colleagues, right? Then I asked like help from my colleagues where they can like upload the pictures. And once the new training has started, it was able to detect like pretty much everyone's face based on the quality of the model. Okay. So now we are able to run that in the browser. Okay, that's fine. But how we are going to run this in the IoT devices? Because that's where this actual use cases, right? So for that one, before doing that, I am going to give some introduction about the device I'm going to use. Okay, so I will explain like how that the Edge TPU will work, right? So did you remember like this is the diagram I have shown when I'm explaining the cloud IoT. So here, all the machine learning analysis that's happening on the cloud, but in the cloud IoT Edge, where Google is providing this framework. So using this cloud IoT Edge, you are doing that analysis on your device instead of doing it in the cloud. So basically, you are doing all those decision making in the device itself, so that you don't unnecessarily like sending the data to the cloud. Right? So here we have all the sensor, and the data is sending, and this edge device framework that has this cloud IoT Edge runtime, and you need to deploy your machine learning models into the devices here. And this edge runtime, making sure you are able to run your inference on your device itself. And also using this Cloud IoT Edge runtime in your Edge TPU instead of CPU, it would be more fast inference than like when you run it on the CPU. What does that mean is, I will show you like what's that Edge TPU when it comes to the Raspberry Pi, right? So the Edge TPU, the Google Coral Dev Board, it is having like an embedded Edge TPU. So this is where your machine learning model is going to run. If you don't have like a Google Coral Dev Board, you can run it on your own device, but you need to bring the USB-based accelerator. Basically, it would accelerate your machine learning models. Yeah, yes.
Hey, Siva. So we do have one
Sorry,
question in the chat. It's and I already lost it. That's my own stupid mistake. So the question was around, the AI model and everything. Does it filter objects? Like, for example, if you're wearing a mask? Oh, were you able to hear me?
Send me the question in the chat. Sorry, I'm not able to hear you. We need to. The question is that does it filter the mask? Right? We need to train a new set of category for that. Like for example, if you want to detect whether the person is touching the face or not, and also you need to make sure not only the danger and safe, you need to say like a very safe. Then at the time, if the person is wearing the mask, at the time you need to label that category as like a very safe. So basically, you need to add like more data and making sure whatever that scenario that's fall under the right category. Then the machine learning model, it would be like fine tune again, so that like it can detect whether you are like covering face like this with a hat or covering face with your mask, right? Okay. So now I'm talking about this, the USB accelerator. So you can run this machine learning model if you have only CPU based device, for example, Raspberry Pi here. But you want like the high fast inference, right? At the time, you can use this USB accelerator. This is the Google Coral Edge TPU accelerator. It has the Edge TPU. You need to connect this USB device with your Raspberry Pi. And whenever you are using the Edge TPU framework here, it would make sure the model is transferred to your this USB accelerator, and all the inferences are running from the accelerator. I will show that kit demo to you, like how that fast it's going to look like. For that, I need to connect to this the Raspberry Pi. Right now, I am connecting to the VNC. The first thing I will show you how it differs from CPU inference and also the Edge TPU inference. One second, hold on. I will step back. Before that, I will complete showing this demo, like how the face detection looks like. Right. So I have exported my model to the Edge TPU based model, and I have this the label also. So you can see it's doing like the inference in 5 milliseconds, and also it's saying like what is the ratio it's detecting the label. Now it's safe, but if I'm placing my hands in the face, you can see like it's detecting a stager with a high ratio here. Now I'm taking it again. It should be safe on top, but you can see like it's struggling between like finding safe and danger with a close ratio like 0.5 something. But if I'm keeping my hand, then it's pretty solid, like it's more than 70%. It's sure it's danger, right? So I need to make sure that I'm updating more safe data as well, so that it can predict correctly. Right? So that's how this detection works on that Raspberry Pi with the Cloud Edge TPU accelerator. Now I will show you how the running the inference between CPU and TPU will differ, right? So I have one of this board detection model. First, I'm going to run it in the non-edge based. So now the inference is going to run on the Raspberry Pi itself. It's not going to run on the accelerator. So I'm detecting some of the board image. You can see it's taking like 120 to 130 milliseconds, right? But now I'm going to run this using Edge TPU. So you can see like the model is different from this one. So I'm going to run probably the same image here. You can see it's transferring the model to the USB accelerator. So that's why you can see like only 17.7 milliseconds here. Even though it's the first time, it's pretty faster than running the inference on CPU, right? But after that, it's not like it's not taking this much time itself. It's taking like less than 5 seconds. So think about like you are detecting the same image or same feed, but if you are running from the CPU, you're taking like 130 milliseconds. But if you are running in the Edge TPU, that's the applied system integration circuit model. So if you're running that, it's making like the fast inference. So using this kind of like fast inference, you can take like a decision pretty quick. And that also, in case of like offline devices or edge devices, you are having like the fast inference help you to take like a faster decisions on your actions. So that's how it works. And you can run the same thing on like a Coral Edge board itself. At the time, even you will not take this first time latency, because it's embedded with the board itself. So this is the thing I have shown. Yeah, this donut zone is like one of the other industrial use cases. Previously, I have presented this talk previously in the DevFest Florida. If you have attended previously, I think you might know the scenario I have explained in that. So I have get some of the donuts like this, whether it's okay or not okay. If it is crushed or something like that in the industry cases, then that's not okay. If it is perfect shaped donut, then that's okay, right? Then I detected like I basically like simulated the environment like it's the camera is on top of the conveyor belt and the donuts is pausing. Whether it was able to detect like whether it's perfect shape or is crushed one. So that's like one of the industrial use cases I was demoing before. Now I was demoing like this COVID things also. But if you have like a more and more data, you will have like a more high quality training model. And also you need to make sure
Just hopping back on here, Siva, we lost your audio. See if we can get you back. Your video is still here, but oh, you're back. Okay, hopping you back over. Just a second.
oh, okay.
Go ahead.
When did you lose? Should I reply?
Hard to say. May as well.
Okay, I will start from this donut scenario.
Sounds good.
Okay. So if you have attended my DevFest Florida before, I have demoed this donut scenario, right? So the scenario is like we are going to place a camera on top of the conveyor belt, and the Edge TPU is going to detect like whether the donut is perfect shape or not. Basically, doing the quality control check, right? So I have uploaded the images like the perfect shaped donut and also like the crushed donut, and detect like whether it's okay or not okay. And I run this demo on like the HTPU, the same demo, and it was able to detect like the okay or not okay. So this is one of the industrial use case I was demoed before, but think about like the other use cases we can do. You have wherever like you are detecting and you need to take the decisions, you can train your custom models and start doing that. You don't necessarily to build like the deep learning VMs and other stuff, at least for initial cut and making sure you are proving the point. You can start doing with AutoML. That's taking all of your heavy lifting, training the models from you, and making sure you are hitting the market with like a fewer steps with high intelligence on your edge devices. Okay, so and also these are like the object detection, not only the classification. They have this object detection, so you can do this object detection to make sure it's able to detect like what are the objects here. I will show that demo as well. Give me a second. I think it's here. Okay, so here I'm starting detecting the webcam with the model passed in this thing. So now it's detecting like I'm the person, and it's detecting like whether it's a cell phone. So if I'm bringing that cell phone, it's making. Let's see whether it's able to detect hand sanitizer or something like that. It says that also 100%. Okay, so based on like the different objects, it's able to detect all these commonly used labels that are embedded in that model. So you can use these kind of object detection also, not only the classification, you can do the object detection as well. Okay, any questions so far?
No, we're not seeing anything in the chat unless anyone wants to type something up really quickly. I know there's a delay, so I don't know how long to actually wait.
Okay. So the key. Yeah. Okay. I have thank you slide here. So the key takeaway is like you can run the high-speed machine learning inference using Edge TPU even on your low-power devices. With the Raspberry Pi, I'm using this USB accelerator to run this the fast inference from 180 milliseconds to 5 milliseconds, right? And also you can use Cloud AutoML to train and export your model. Even like the cloud hosted or your edge devices, you can use that model. And also I have explained like how the transfer learning works. If you're adding more data and doing the training, it will take the learning from the previous iteration. It will not do learning from like initial sets, right? And also you can try this Edge TPU. Basically that's a ASIC model. Using either like a correlator board or the USB accelerator, you can try and use this one, right? And I have like a couple of reference slides where you can get this dev kit and accelerator, and where you can read this Cloud IoT core. And this demo on the slide, it may have the donut slide. I will update this COVID-19 slide also in the same link here. And finally, as we are here and in this situation, remember always like there's a great, big, beautiful tomorrow shining at the end of every day. So yeah, let's be with the hope and make sure you are learning and sharing and be part of this community. And let's attend these kind of meetups and making sure we are extending our support to others. Hopefully we will be coming out of this soon. Thank you.
Cool. All right. Well, thanks, Siva. That was a really cool presentation. The chat's been blowing up about yummy donuts, and does the computer really know if they taste good or not? I'm not so sure, but at least we know if they look good.
Questions from the chat, so I'll just ask those pretty quickly. So the first one is, and you showed the link to your GitHub profile where the slides are. So someone was asking if those were available, and then you showed the slide. So they are, but as far as a direct link, either if you want to, you can either share that with me now, and I'll put that in the chat, or we can put that in the Meetup page as something. But we'll make sure that everyone's alerted with that.
Yeah, I shared in the chat.
Oh, perfect. Well, then I will copy paste that right now and share that with everyone else. And then the other question was, and now I have to scroll for it because I just put something into the chat. So Google Photos creates models for faces found in your own photos. Do you know, is there any way to access those models? I'm assuming they're asking this question as a, hey, are these, is there a way to get those models for your own, just to have another sample size?
I'm not sure about that, but Google has like exporting your data. They didn't provide that option like exporting your model yet, right? Maybe in future they may give that access like, okay, these are the machine learning stuff we have done based on your pictures. You own that, so you can take care of that. If they come with that kind of the privacy, then you can use. Right now, like they are keeping it as a data, not like the model stuff.
Gotcha. So that one's probably more of a trade secret kind of thing, huh?
Yes.
All right, and that's it for the questions in the chat.
Okay, cool.
All right, well, I guess I'll take it back over. Looks like we're running right on time. Probably, why don't we take 1 or 2 minutes here for a bio break so we can get Javier all hooked up and we can have his presentation. So with that, I'll probably cut you guys back to the picture and then we'll reconvene in about 2 minutes. All right, see you guys then. All right, everybody. Hope we didn't lose too many of you. It is time now for Javier's presentation on how to make some money in this space. Hey, so let's cut over.
For having me. So I'll give a little background on myself. Basically, I'm one of the co-founders and the senior technical recruiter at Higher Llama. We specialize in connecting top mid to senior level engineers with fast-growing companies, mostly startups right now, like venture-funded startups, or anyone that's like in Series A or Series B. I used to be a .NET developer. I built Windows 8 and Windows 10 applications, but I wasn't really good. So I made the jump to tech recruiting. I know everything's going crazy right now, but if you are an IoT or if you're, any type of like device, place, and if you're working there, then you are a hot commodity, especially, engineers with that type of skill set. So, there is right now, for example, since my company works with a lot of startups, I would recommend researching, like, these are some of the websites that I post up, like, there's angelco.com, LinkedIn has job posting by startups. There's, co-working boards. So for example, which I'll do this, like if you, like this is a co-working space called Groundswell in Melbourne, Florida. So it's Orlando's neighbor, but they have a lot of IoT companies that work out of there, and they have garages and everything. So if you go to their job board, you can see job postings. And if anyone's in, like there's a CTO position, there's a robotics company, a stealth company. So I think in general, developers are always in high demand, especially good ones. But if you're in IoT and devices, like startups are really, really starting to grow right now. In Florida, surprisingly, has a really good hold on it right now. And there's a few reasons because of that. So, back to the startups, I would also, just get yourself out there, go to as many like job posting boards, because that's usually how they find talent. But, also reach out to your community. So I know in Orlando, there's a Digital Orlando. There's a ton of community spaces that are always looking to recruit. So I would do that. The next one which is my favorite, is I would recommend, if you're in an IoT space right now, is to actually, start your own venture or work as a government contractor. And the reason I say that is, again, I'm going to take out of this. The United States has a really cool program called the SBIR, and it's basically free money to build anything you want. Obviously, there's topics. So like if we go to their website, we can look at the listings. There's phase 1 funding. There's a blueprint neurotherapeutic network, small molecule drug discovery and development for disorders of the nervous system. Obviously, this is different, but there's so many contracts out there right now. And you can, you could work by yourself. You could hire your own team. You could partner up with the big company like Raytheon or something. And there's also the ability to, be a subcontractor as well. So I would honestly take a good look at this, especially if you want to, get your entrepreneurial itch figured out. And let's go a little further into one. So for example, here is everything is, by the way, is public. So if you win a contract, they will publicize all the information. They'll say how much your contract is worth. So for example, here someone won a contract from NASA. They won $740,000. And in this, you see the solicitation number. It's for 2018. They awarded it this year. This contract is for 2 years. It says who won it. So this is open to anyone. So you don't need to hire someone. You just need to be really good at writing grants, and also like at least have some industry knowledge, because the more experience you have, the better it is for you when you apply for these things. Again, then there's another tool, if you're looking to go on your own and start your own venture, it's called grants.gov. Again, in this website, there's over 2,900 forecasted and posted things. And this is anything from IoT or devices or anything hardcore where you're building stuff. So I would seriously recommend this, giving it a little bit of time. And, if you do really want to do this, I would suggest, at least for now, because of the current economic situation, reaching out to like the SBA and talking to them on how you could get started, because there are some programs that would just, help you, teach you how to do government grant writing and teach you who to talk to. There's also PTAC, which is they help you basically write the contracts, and they review it for you. They give you a score, because surprisingly, when you do apply for contracts with the government, it's not really, you don't need to be the best person, but you need to know how to write the contract. And they usually grade it based on answering the questions on this stuff. And, like I said, back to SBIR and STTR, and those are amazing programs. You don't need to pay back any of the money they give you. I know somebody in New York who, she was actually working in finance, and she wanted to do something in AI and virtual reality. And she won a $3 million contract from SBIR. She never built any web projects. She never did any coding, and she won it. And then with that $3 million, she hired a team to build the product that she wrote the grant for. So that's what I would say, suggest if you're going to start right now, go the government route, or, team up with somebody that has experience there. There's also, you could work for the government yourself. I would say there's two types of levels when you're working for government, especially in the IoT. You could go for one of the big defense contractors. They have a lot of jobs opening, and it's everywhere. Right now, you could apply to Lockheed Martin or Raytheon in Melbourne, and you would probably get a call back in like a day or two. Now, if you were in the military, IoT, I would say, and you have a secret clearance, it's amazing, because right now, there's regular defense contractors, software engineers, and then there's top secret or clearance level projects that they can only hire developers that have those classifications. And just to give you a number, when you go from a regular developer, you're making like 110. When you go to secret and you have that type of clearance, you're probably easily getting 180, 190. Like it's that fast. So, people that were in the military, they're actually transitioning into development jobs right now. But if you were in the military, I would recommend you apply for, top secret or classified jobs. Another thing I would recommend anyone to make money right now is just like contact recruiters. A lot of, because of the pandemic, a lot of jobs are getting lost, but a lot of startups and, big corporations are looking for more engineering talent. And obviously you could apply on their website, you could look at the career pages, but working with the recruiter actually helps you get your pretty much the highest salary you can demand, and you can get perks and benefits. Let's say a company in California wants to hire you. You guys we're in Orlando, so you can easily ask for the highest salary. If they like you, you can ask for a really high salary. And as a recruiter, just to be upfront, we on average make 20% of your annual salary as our placement fee or as our finder fee. So if I get you a placement in a California company that's going to pay you $200,000, I'll get $40,000 as my payout. So I am incentivized to get you the highest paying job. And also I can probably negotiate for you as well to get even more payment. Like if you were to move to a different state, you could get maybe up to $10,000 just to relocate fee. They can, fly you out, put you in a hotel for a month. That way you don't even have to pay rent. So there's a bunch of things that recruiters know and how to help you find the right company. And salary is a big one. Another reason I work with recruiters is that, our job is so on top of placing you, we usually guarantee that you're going to stay with somebody for at least 3 months. And if in those 3 months you leave, we lose our placement fee. We have to refund it or give a credit. So we don't try to match developers with companies we don't think they would succeed in, or we would try to find them the best company, like the best culture fit. So, this is pretty much a free service because recruiters talk to a lot of people every day. I probably send 20 to 30 emails a day, either on like potential talent that I'm interested in, talking to place with somebody, or, interviewing or screening some people. And that's pretty much it. A couple other tools I want to show off is like the startup Angel Co. This is a website. It's called angelco.jobs. If you're into startups, you could go here. You could find a ton of openings. These are obviously not good ones, but you could look. There's openings all over the world. If you're into like really high tech, like New York City jobs, they have this thing called Built-in NYC. You can apply for system engineers, digital marketing. There's a bunch of things available. I know here locally, SpaceX is hiring really, really aggressively. So you can go to Cape Canaveral. They're right there. And I think last month they hired over 50 people in the IoT field. Again, back to like job boards and like startup places, you can look at that as well. And that's pretty much it.
Hey, that was great. So we do have one question so far in the chat,
Yeah.
so I'll just go ahead with that one. So at the beginning, you were talking about a lot of IoT-related jobs out here in Orlando. So the question was, what are the reasons you think Florida has a grip on this space currently?
Well, the simplest answer is there's a lot of defense contractors here. So there's a ton of them, especially like, for example, I'm not sure of the exact number in Orlando, but Space Coast, where like NASA is and SpaceX is, there's Raytheon, Northrop Grumman, Lockheed Martin, and each one of them alone employed like 40,000 engineers. So there's a big concentration of defense contractors in this area, and there's also like the heritage of like NASA being here that's made it a really attractive area.
Gotcha. Cool. All right. I don't see any other questions in the chat. I guess we can wait a little bit more just to see. Oh, there's another one. What are some examples of jobs you've seen out here in the IoT space?
So, for example, this company, Tomahawk Robotics, I met them. They were hiring 3 engineers, and they were having a really hard time finding them. But a big reason is like people don't know that they were hiring. So like they had a LinkedIn page, but a lot of people didn't see it. So there's there's Tomahawk. There's other companies like the packaging one right here. I think there's a few others, and especially like Northrop, like Lockheed is hiring crazy amounts. I would look at them as well.
Cool. So another question. So I get that you may not be able to talk or not be able to get into specifics, but what skills are you seeing being really in demand?
Right now, there's a huge demand in networking. So if you know how to work with like 4G and 5G, like telecom towers, broadcasting, all that, it's really, really in demand. People are not able to find those jobs, and you can't really like outsource that because you have to be working with the device in person. And there's also like some limitations based on government like requirements on these jobs that you can't outsource at all. So engineering is a huge one. Electrical engineering right now is in big demand. Battery engineers, I would say IoT is really big as well, but in that circle. So like if you know how to make devices 5G compatible or 5G ready, then you can, talk to any recruiter, they'll want to hire you immediately.
Cool. All right. So next question: will these slides be available online? So I don't know if you have them stored anywhere. If we can share a link.
Yeah, I'm going to add more stuff to it of the websites I know, just like some lists, and then please feel free to look at them.
Okay. Cool. Sounds good. So we'll make sure that everyone can at least get that in some way, that link. And then last question that I'm seeing so far in the chat is, I guess they're asking, do you know if there are any new jobs in the UCF Research Park?
That one I would have to check, but I would check out their careers page to make sure. But they should, if it's anything in IoT, they should still be hiring. And the safest bet is again like go government, because government may have contracts with UCF, and they may not advertise it as working with UCF, but they probably have a bunch of contracts that works directly with the UCF campus.
Cool. So another question just came in. So on the software side of things specifically, are there any specific skills that you've seen as being in demand? So like programming languages, platforms, etc.
For front end, I'm seeing a lot of demand of MERN. The React JS language is in huge demand. Flutter is starting to catch up a lot. I would say if you know how to work with Raspberry Pi stuff, then you're in demand. You're looking at like a premium of like 10 to 20% for your next job over like a typical software developer job.
Wow. All right. That is some good stuff to know. I'm not seeing any other questions in the chat, so I think Jared, who asked like half of those, has probably run out of questions. I feel like he was probably trying to think of some. So now I'm just going on a tangent, kind of waiting a little bit to see if anyone else pops up any other questions. And I guess not. So yeah, I guess that's it from everyone as far as questions.
Awesome. Well, yeah, thank you for having me.
All right, I'll fade us back in here to this giant multi-box and turn off the echo machine. Let's see. There we go. Okay, well, from all of us who are still on their webcams, thank you so much for joining both the Google Developers Group and Orlando IoT. This is groundbreaking for us, and I hope you guys had a good time. If you can think of a better way to do this, I'd love to be able to see all of your faces and hear all of your voices. Apparently, Jared's going drinking. But there we go. But yeah, so it was great to have all of you. I can't wait to do this again in the future. It looks like we've got one coming up, another meetup here. Let's see, let me get to that slide again. We've got the Firebase meetup on April 23rd, which is limited space, so make sure you sign up for that on the Google Developers Group page. And then on May 6th, the Orlando IoT Group will have our next meetup. We're trying to work on something where you can sort of hack along with us, especially in the IoT space. Maybe something where we like all share a LED light where we can change the colors of it and just sort of do a mass hack. So stay tuned for details on that. We'll try to get some stuff together. But yeah, anybody else want to say anything here before we sign off? Nope. Alrighty. Well, all of you 30 concurrent viewers we've got, thanks for joining us, and we'll talk to you in the future. Stay safe, everybody. Bye-bye.